What's up, you freaking geniuses? So in this video, I'm going to teach you how to find the domain of a composite function, all right? So here we're going to start with this first example. We have f of x is equal to the square root of x plus 4, and g of x is equal to x squared. So the composite function that we're going to want to find is f of g of x. Okay, now here there's two domains that we have to look at. First of all, we have to look at g of x and see if there's any restrictions on this domain. And then we also have to look at f of g of x and see if there's any restrictions on this domain. So first of all, let's figure out what f of g of x is equal to. So here what we're doing is basically just plugging in g of x in for x right here, right? We want to plug in g of x right here for x. So wherever we have an x in our function, so this one right here, that's where we want to plug in g of x. And what is g of x? Well, it's just x squared, right? So all we want to do is plug in this case, an x squared in for this x. Okay, so here f of g of x is going to be equal to the square root, and then here instead of x, we're going to write x squared, and then we still have this plus 4, right? All right, so now that we found the composite function, now we would just want to find the domain of this function, all right? And when you're looking for the domain of a function, all you're really looking for is what numbers can you not plug into that function, right? So for instance, here, this is a square root, right? So any number that we plug into a square root can't pop out a negative number. Okay, so here, for instance, let's just plug in a super simple number. Let's just start with 0. Can we plug in a 0 for x? Will plugging 0 into this function break the function? Will it break this square root? Well, if we plug in a 0 for x, here we're going to get 0 squared, which is just 0, and then we're going to end up with 0 plus 4, so we're going to end up with the square root of 4. Totally fine, right? Because we're taking the square root of a positive number. Now, what if we plug in a 1, right? Same thing. If we plug in a 1 right here, we're going to get 1 squared is equal to 1, and 1 plus 4 is equal to 5. And we can take the square root of positive 5. That's totally fine. Now, what if we plug in a negative number, all right? What if we plugged in negative 1, all right? Well, if we plug in, let's just write it out. If we plug in negative 1 here, that's going to be equal to the square root of negative 1 squared plus 4. Now, when you square a negative number, it turns it positive, right? So this is actually going to be equal to the square root of positive 1 plus 4. So here we still end up getting the square root of 5, which is a positive number. Okay, so as you can see, we can plug in positive and negative numbers in here for x, and it's going to be fine. So in this case, for this composite function f of g of x, the domain is going to be all real numbers, right? Or you could write it in interval notation as from negative infinity to positive infinity, right? Same thing. All right, great. So we found one of our domains right here. Now let's figure out the domain of this guy right here. G of x is equal to x squared. All right, so again, we just want to figure out what numbers will break our function, right? Well, here, no number is going to break our function. We can plug in any positive or negative number or 0 into this function and square it, and it'll be fine, right? We're not breaking any math rules. So here, you can see that the domain would also be all real numbers, right? So as you can see, neither f of g of x or g of x have any restrictions, right? The domains of both of them are all real numbers. So the domain of the composite function, f of g of x, would be simply all real numbers. All right, here's the next example we're going to cover. So we have f of x is equal to x to the 5th, and g of x is equal to the 4th root of x. All right. So again, the first thing we want to do is find f of g of x, right? So let's find f of g of x. All right, so again here, we just want to plug in g of x into the function wherever we have an x. So that's just going to be this spot right here. So this is where we're going to plug in g of x, and g of x, as you can see, is the 4th root of x, right? So we're going to plug in the 4th root of x right there for this x. So here, f of g of x is going to be equal to the 4th root of x, and then I'm going to put this in parentheses, because as you can see, we're still raising this whole thing to the 5th power, right? So we're going to put that big ass 5 right there. All right, so now that we've found f of g of x, now let's figure out what the domain is, right? So are there any numbers that we can plug in for x that would break our function or break some math rules? Okay, so can we take the 4th root of both positive and negative numbers? And the answer would be no, okay? Because square roots, right, this is what a square root looks like, can only be positive, right? And to make it clear, So this little number right here next to the radical, that's called the index. So just a regular square root technically has a 2 right there, but we normally just don't write it because it's already implied. But we know that we can only take the square root of positive numbers, right? Same thing with any even numbered root. So the 4th root, you can only take positive numbers. The 6th root, you can only take the positive numbers, right? 8th, 10th roots, etc. Now, on the other hand, odd numbered, so like a cube root, you can take positive and negative, right? 5th root, you can take positive and negative, and so on, all right? So here, the 4th root of x, we cannot plug in any negative numbers in here for x, all right? We can plug in a 0 or any positive number, but we can't plug in any negative numbers. So in this case, the domain for f of g of x is going to be restricted from 0 all the way to positive infinity. Okay, so we found this domain, and then lastly, let's look at the domain of just g of x. Well, it's also equal to just the 4th root of x, so the domain is going to be the exact same, right? It's simply going to be, let's write it like this, from 0 to infinity, all right? So as you can see, they both have the exact same domain. So the domain for this composite function right here would be, again, from 0, including 0, so we put a bracket, to positive infinity. All right, now let's do this one right here, and this is going to be kind of the first kind of challenging one that we're going to run into. So here we have f of x is equal to x squared minus 9, and g of x is equal to the square root of 9 minus x squared. All right, so again, let's just start at the same place, finding f of g of x, right? So f of g of x, all right? So we just want to plug in g of x in here for x, so we're going to plug in g of x right here for this x, right? And g of x, as you can see, is the square root of 9 minus x squared, right? So then here, f of g of x is going to be, it's going to be equal to the square root of 9 minus x squared, and I'm going to put that in parentheses because as you can see, we're squaring this whole thing, right? So we're going to square that, and then we have this minus 9 right here at the end. All right. Now, as you can see, we are squaring a square root. And whenever you square a square root, those cancel out, and you're simply left with whatever was under the radical. So here, that would just be 9 minus x squared, right? So then here, f of g of x is going to be equal to 9 minus x squared, and then we have our minus 9 out here. Okay, so then here, as you can see, we're going to have 9 minus 9, so those cancel out, and we're simply left with negative x squared. All right, so f of g of x is equal to negative x squared. So let's find the domain, all right? Let's figure out what this is. So can we plug in any positive and negative numbers in here for x? Will doing that break our function? No, it won't, right? We can plug in any number here for x, and it'll be totally fine. So then here, the domain is going to be all real numbers. All right, now let's figure out what the domain of g of x is. So g of x, again, is equal to the square root of 9 minus x squared. So remember, we cannot take the square root of negative numbers, all right? So is there any number that we can plug in here for x that would spit out a negative number? Well, there is, right? So any number that we plug in here that will be something bigger than 9 is going to give us a negative number. So for instance, let's plug in a 5 for x right here, okay? So if we do that, this is going to be equal to the square root of 9 minus 5 squared. So this is going to be equal to the square root of 9 minus 25, which is equal to the square root of negative 16, and that doesn't work, right? So to figure out which numbers we can plug in and which numbers we can't plug in, we need to set up an inequality, all right? So what we're going to say is we're going to take whatever is under the radical, so 9 minus x squared, and we're going to say that it has to be greater than or equal to 0. Okay, now in order to solve this inequality, we first have to factor this side, this 9 minus x squared. Now, one convenient little thing that we have going on here is that 9 is a perfect square, right? 9 is the same thing as 3 squared. So let's rewrite it as 3 squared, and then again, we're still subtracting x squared, and we're saying that that's greater than or equal to 0. All right, what was the point of breaking it down as 3 squared? Well, because as you can see now, we have a difference of 2 squares, right? 3 squared and x squared. And we can easily factor a difference of two squares, right? There's that little rule that says that you're going to put these into parentheses, and then you're just going to use the bases, so 3 and x. So you're going to say 3 plus x and 3 minus x, all right? That's how you factor a difference of two squares. And again, we're saying that this is greater than or equal to 0. Okay, great. So as you can see, we factored this completely, and we have two factors left, right? 3 plus x and 3 minus x. So to figure out what our limits are, to see what we can plug into here, we're going to take each of these factors, so 3 plus x and 3 minus x, and we're going to set each one equal to 0. Okay, now we're just going to solve for x. Okay, so we're going to have two solutions basically, right? So for this first one, let's subtract 3 from both sides. Those cancel out. So here we get that x is equal to -3, right? And then on this side, let's add x to both sides. That seems like the easier route. So then here we're going to get that 3 is equal to just x. Or I can write that the other way, right? We could say x is equal to 3. Let's just do that, just so it matches this one. So x is equal to -3 and x is equal to +3. All right, great. So now that we found our 2 points of interest, we're simply going to graph those on a number line, all right? So we're going to say this is -3 and this is +3, all right? Also, notice that I am filling in this circle that I'm drawing. And the reason that I'm filling in these circles is because the inequality symbol that we have has an equal to symbol attached to it, okay? If it didn't have that equal to symbol, then we would draw open circles at these points of interest, all right? Now, the last thing we have to do is simply test a point in each part of this number line. So we want to test the point here on the left side, here in between them, and on the right. Okay, and a convenient way of doing that is by using something called sign analysis, right? So basically, we just want to pick some number over here on the left side. So let's just pick -5, right? Since that was one of the numbers I kind of just tested initially. Let's figure out what would happen if I plugged in a -5 for x over here, okay? So if I plug in a -5 right here, well, 3 plus -5 would be -2, so that's a negative number. And if I plug in a negative number over here for this other set of parentheses, we'd have 3 minus -5, which is the same thing as 3 plus 5, which is a positive number. Okay, now a negative number times a positive number is a negative number, right? So then that means this region over here that we just tested, we're going to write a negative symbol, okay? Now let's pick a number in between -3 and 3, and the easy number that I can think of right now is 0, okay? So if we plug in a 0 into our inequality, first if we plug in a 0 right here for this x, 3 plus 0, that would just be 3, so that's a positive number. And if we plug in a 0 right here for this x, 3 minus 0 is still just +3, right? So then we get a positive times a positive, which is equal to a positive, right? So then this middle region, we're going to have a positive symbol. Now lastly, let's test a number out here on the right side. So let's do +5. That'd be easy, right? So if we plug in a +5 into our inequality, here we'll have 3 plus 5, which is 8. So that's a positive number. And on this one, 3 minus 5, that's equal to -2. So that's a negative number. So then a positive times a negative, again, is a negative. So we're going to have a negative symbol out here. Okay, now you might be wondering what these symbols mean, which is a great thing to wonder right now. So looking at our inequality again, we're saying that this thing right here has to be greater than or equal to 0, right? Or in other words, we're saying that this thing right here has to be positive, right? Because positive numbers are greater than or equal to 0. So our solutions are wherever we have a positive symbol. And that positive symbol happens to be right here between -3 and +3, okay? So this is where our solutions lie. This is where the numbers we're allowed to plug in are, okay? Or in other words, our domain. So the domain, as you can see, goes from -3 to +3, and it includes both of those numbers, right? So we're going to say the domain goes from -3 to +3. Okay, so going back to f of g of x, remember this one didn't have any restrictions on the domain, but g of x does have restrictions on the domain, and the restrictions always win, all right? So the domain of this composite function, f of g of x, is right here, from -3 to +3. All right, boys and girls, let's do one last one. So here we have f of x is equal to 3 over x squared minus 1, and g of x is equal to x plus 1. All right, so again, let's start by finding f of g of x. All right, there you are, f of g of x. So again, we just want to plug in g of x wherever we have an x in the function. So here, that would be for this x right here, okay? So we want to plug in g of x, which is x plus 1, right? So we're going to plug in x plus 1 right here for this x. So f of g of x is going to be equal to 3 over, and then instead of x squared, we're going to have x plus 1 squared minus 1. Okay, now here we can multiply this out, right? So x plus 1 times x plus 1, let's do that. So then here, this is going to be equal to 3, and then here we're going to have x plus 1 times x plus 1, and then minus 1. And now to multiply these together, we can simply FOIL them, right? So we're going to have 3 over, and then foiling that, let's actually do it off to the side right here. Let's see, x squared plus 1x plus 1x plus 1. So combining like terms, that's going to be x squared plus 2x plus 1, and then we have this minus 1 right there, okay? Now here, as you can see, we have this plus 1 minus 1, so they're going to kill each other. So we're simply going to be left with x squared plus 2x. Okay, so let's just write it over here. We're going to be left with, let's write it there, 3 over x squared plus 2x. All right, that's pretty simplified right there. So now let's find the domain. So are there any numbers that we can plug in for x that would destroy this function or break some math rules? Well, there are, right? So remember, you can never have a 0 in the denominator of a fraction, right? Because you can't divide by 0. So in order to figure out what number would make this bottom section equal 0, all you have to do is set the bottom equal to 0, okay? So then here, the first thing we can do to solve for x is factor out an x from both of these terms. So we're going to get x times x plus 2 is equal to 0, okay? So as you can see, we have two factors, right? X and x plus 2. So to solve for those, you set each one equal to 0. So the first one, we're going to say x is equal to 0, and then we're going to say x plus 2 is equal to 0, right? So solving for the first one, well, there's nothing to solve. It already solved itself. We already have one solution right here, so x is equal to 0. And then here we can see, right, just subtract 2 from both sides. So we get that x is equal to negative 2, all right? So we get two numbers, right, that would make this denominator equal 0. Okay, so we can plug in any numbers into this denominator. It'll be fine, except for 0 and negative 2, all right? Let's get rid of that crap right there. So here we would say that the domain goes from negative infinity, and then it comes all the way to negative 2. But we're not going to include negative 2, right? We're not going to put a bracket here because we can't put negative 2 in the denominator, okay? And then we're going to say union, and then we can go from negative 2 to 0. That's fine. The numbers in between there are fine, all right? But we're not, again, not including those two numbers, so parentheses. And then we're going to put another union symbol, and I'm going to clean this up. And then we're going to say we can go from 0 to infinity. Okay, so again, this is the domain for f of g of x. Now lastly, the domain of g of x. Well, here we just have x plus 1. So here you can see we can plug in any positive, negative number, or 0 in for x, and it's not going to break this function, right? So the domain is all real numbers, okay? But like I said, the restrictive domain always wins. So that means the domain for this composite function for f of g of x is this guy right here. Boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.